Good afternoon all, and thanks for the opportunity to let me present this to you. I was very impressed by the morning speakers especially, who seemed to have presented the level of all the activities of the Interfacer project just right, not too high or not too low. And in the spirit of some of the earlier presenters, I'd like to present fairly quickly and then open the space for a little more questions and discussions, because I think there's a sort of a magical impression around this concept of digital product passports. I'd like to dive into it a little deeper and then go into some dialogue about it. Okay, first of all, I've got a fairly text-heavy beginning, but I'd like to go through it and underline what some of the previous speakers have already gone through, just briefly. And to begin with, I'd like to just outline the rationale for the so-called digital product passport again. It came from the European Commission's strategy of the Green Deal. And from that evolved some eco-design principles and a proposal for an eco-design for sustainable products regulation that's still under review, as William Neal specified earlier this morning. And its aims really are to try to embrace the entire life cycle of products, from the conception and the design to its production, to its everyday use, to its disuse and eventual recycling or disposal. And it's meant to increase in terms of design, where, as was also previously stated, 80% of the improvements of sustainability can begin at the first layers of the design phase of a product's life. So it increases sustainability for consumers to allow them to enjoy the products and the needs that the products satisfy for longer, and presumably with enough monitoring can also help with sustainability in terms of the primary resources required for its manufacturing, its usage and its disposal in terms of electricity, water and so on. Achieving a circular economy, allowing for opportunities to reuse, recycle and repurpose products, again, throughout their life cycle, and to provide locality information, which helps with the energy minimization of redistribution of products and their components, repair processes and so on. And finally, that was also outlined in some of the previous talks this morning, and that is about opportunities and insights for alternative business models instead of our extractive linear model at the moment of assuming that a design is made and then a product is distributed en masse globally in large numbers, to look at alternate business models that can consume less throughout the product lifestyles. For example, service-based on-demand models of manufacturing and usage. So the Interfacer project and the FabCity OS has designed a DPP implementation that is compatible with the EU aims and objectives, but also tries to add some features that are useful for collaborative and distributed product life cycles, especially, as Jeremy has said earlier in the morning, within the design phase. But we've kept the architectural view that the system should hold up throughout the entire life cycle. Okay, so what exactly is a DPP, a digital product passport? Well, in essence, there are two parts of a digital product passport. And within the European legislation, the regulation proposals, there is a concept called a data carrier. This will be the most visible part of a DPP. In this case, it's visualized as a QR code that many people are familiar with. But it's not limited to just that. It can, of course, be an RFID chip or other known parts of encapsulating machine-readable data. Okay, and this data consists primarily of a product identifier code and some other details that are important, including a location to reference to linked data. Because this is a small code, it can't contain entire product histories by itself physically, but it can point you to reliable sources that point to the history of that product. And finally, it also contains verifiable cryptographic data that can assure and give confidence to the authenticity of both the linked data and the identification, as well as the integrity of this data. The linked data itself is meant to include a lot of information. Trawling through the European draft legislation is an arduous task to extract this out, but in an upcoming article for a book as an output result of this project, we go into that in tabular depth. But briefly, there are identifier codes for stakeholders, people, of source components and materials of products, and people, of course, who are involved in the manufacturing, design, and, of course, codes that also identified the facilities that are involved in the manufacture of the product. And within the proposed legislation, regulation, further voluntary data sharing is encouraged, which is quite unusual for a regulatory regime. Briefly, again, fairly text-heavy, but really I would like to concentrate only on one part of the more complicated architecture flow here. FabCity OS is a system of tools designed to enable collaborative input and creative input amongst or different FabCity communities, to help encourage and propagate distributed design and manufacturing value chains. It uses a standard called value flows that we will also go through very briefly. This is important because value flows forms the core at the moment of the linked data set for the FabCity DPP. What is value flows? I'll flip through this quickly because it was already described this morning. It's a standard set of vocabularies or a way of speaking and a communication technique for a particular economic model type called an REA model, a resource, event, action, which, as I think it was Jaramil who mentioned earlier, this can be expressed with normal verbs, involving people, things, and stuff that happens to those things through those people. Okay. ZenFlows, which was a small part of the diagram earlier, is an implementation within FabCity OS of interpreting value flows data objects. And value flow data objects are, again, relationships between resources, events, and agents, people, things, and stuff that happens. And you can see a simple diagram of perhaps source materials with events and processes happening to them. Agents are involved in all of those steps. But the definition of tracking is going forward through this process for product development and further collaboration. The reverse is like a trace. This traces a product from where it is right now back to its origins, what makes it up. So instead of field to fork, we've got fork back to field, so to speak. So you'll have a resource and you can trace back the activities and the nature of the people involved and the resources or components that made the product itself. A value flows resource trace forms the heart of a FabCity OS DPP linked data set. And as part of the development of this visualization and the construction of traces and DPPs for FabCity OS participants, we have developed a work-in-progress notebook tool based on an open source system called Jupyter Notebook. Now, Jupyter Notebook has been developed to talk to a FabCity OS server and to help with the input of assembly instructions, so documentation that is actually required for EU digital product passports, but also it's required within the FabCity ecosystem, the community, of sharing assembly instructions and helping with the automated input of those assembly instructions. So using this tool, we can translate the assembly guides that are given in each project into atomic value flow statements that then can be visualized and processed by the FabCity OS, and DPP, digital product passports for the FabCity OS, can then be generated and visualized as well. Hopefully at some stage, I'm not sure of a particular time yet, but I hope myself and some of my colleagues can offer a workshop on the work in progress that is the notebook environment for FabCity participants, to start to show some live demonstrations of assembly instructions being translated into visual representations of the trace that then the DPP QR codes are generated from. So if you are interested in further details of this, I would encourage you to see myself and some of my colleagues at DINE to get a demonstration of this in further detail. Thank you very much for your time. I'd like to open up for any questions in general in this process. This was a lightning explanation, and I hope it was clear enough for most people's initial curiosity.